Hello, Mr. Vessel here, and today what we're going to look at is the 2019 AP Statistics exam 3-response question, problem number 5. And this one has a theme of probability, but specifically it has a couple of different questions about normal distributions and about how to use those probabilities to work with an expected value. So it has several aspects of some probability topics that we'll talk about, and let's dive in here. So this one is about a company that manufactures smartphones, developed a new battery with a longer lifespan than the traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. This is definitely a key phrase here. Means 30, standard deviation is 8. So we're getting our two parameters right along with the fact that it's normal. So this sentence here is an extremely important one as we're going to work through this task here. And we also get some information about the price of the phone, or for the price of 50, not the phone, sorry. For the price of 50, the company offers a 2-year warranty on the new battery. So we get this cost here, and then the warranty guarantees that the smartphone will be replaced at no cost to the customer if the battery no longer works within the 24 months. So purchase the $50 warranty. If it breaks in that first 2 years, you'll get the replacement at no cost. So, with all that information, let's look at part A here. It says, in how many months from the date of the purchase is it expected that 25% of the batteries would no longer work? And justify your response. So it's a couple of ways you could go about this, the justifying piece. There's many ways. One of my favorite tools, and I think you can use this a lot, and a lot of students kind of underutilize this tool, I think, is using the sketch. So since we know it's a normal distribution where mu is 30 and sigma is 8, this is my favorite tool for justification. The normal curve is the mathematics, it is the statistics you can use. So what we know is that the mean is 30, and we also know that the standard deviation is 8, but what we're trying to find in this particular case is the 25% cutoff. So where would this cutoff be for the 25% of the batteries would no longer work? So, if I just estimate where this line might fall, that's really typically good enough. So just going to put it about here. This is trying to shade about 25% of the normal curve. Again, these don't need to be perfect, they never are, but they just need to be able to illustrate what you're working on and show the grader that you know what you're talking about. So this 25% is what we're trying to find in relation to how many months would it take to get to this 25% mark. And in order to do this, you'll need a Z-score, and so there are times when you have to calculate a Z-score and look it up, and other times you get this percentage and you're going to have to look up that Z-score to find some other missing piece. So in this case, I've already looked at the Z-score table. I'll bring it up here. So many choices for students to do this particular task. I really like the Z-score table. I mean, you can use your calculator to do this problem. I find the Z-score table works just as well. So what you're looking for in the table is where this 25% is. So we kind of scroll in here for a minute, and there's always two numbers this thing will fall between. So 2514, 2483, and really if you use either of these two numbers, it's going to work out okay. Sometimes students like to use this 2483 because that's the first one that's just under that 25th percentile. That makes a ton of sense. That would work fine. Sometimes students use the 0.2514 because that one's a little bit closer to the 25th percentile, and that would work too. Either one of these are going to be fine, and I'm going to go with the negative 0.67 in this case. Like I said, both of these are going to be just fine. So this X value has a Z-score of negative 0.67, or approximately negative 0.67. And then what I'm going to try to do here is find this missing X value here. And in order to do that, we have a couple of choices. Some students like to just use your regular old Z-score equation, Z equals X minus mu over sigma. And that works really well. I want to show another way to go about this. I like this method too, where just using the concept of a z-score, and we can just build this equation for x without using that z-score formula. So the data point has a gap, right, from the mean back to this number 30. Now that's got a term, actually. This distance from a data point, which was x, to the mean 30, that's called a deviation. And we also can think of deviation another way. If you take the standard deviation for a sec here, the standard deviation is 8 months. So this represents a typical battery deviation from the mean. And this number down here, our z-score, by definition, a z-score is the number of standard deviations. So what you can use here is that the fact that this gap from here to here is a deviation, but it's also the number of z-scores times the standard deviation. Those are equivalent statements. So one way to just build this calculation for x, you can just take your number 30, that's the mu, and we can subtract off or add the negative z-score. So in this case, our z-score is negative 0.67. Our standard deviation is 8. So we can multiply those two numbers together, and then we can just take that away from the number 30, and we'll get our distance. So the data point x, take our 30 months, and 0.67 times 8 is 5.36. So we can get our number for x here to be 24.64 months. So in how many months from the data purchase is it expected that 25% of the batteries no longer work? The answer to that question is that 24.6 months is the 25th percentile here. 4.64 months is the point where 25% of the batteries will no longer work. And then in the second part of this task, it says suppose one customer who purchases the warranty selected at random. What's the probability that the customer selected will require a replacement within 24 months from the date of purchase because the battery no longer works? So this is kind of flipping it around a little bit. It's not asking you to find a month. It's actually giving you the 24 months as a data point, and then it's asking you to find that probability. And I really think looking at part A just a little bit helps you do part B. So part A, we found just a second ago that 24.6 months would be at the 25th percentile, and where 24 would fall on this exact same diagram, I'm going to redraw, but 24 is going to be right around here. It's just a little bit less than the 24.64, so I do know right away that my answer should be a little bit less than 25%, and I'm going to draw the sketch just a little bit more clearly here. So with part B, what we're trying to find, we know that the mean is 30, that didn't change. We have our data point of 24, and what we're trying to find is this probability here. So this is a direct probability calculation. We want to find the probability that x is less than or equal to 24. So in this case, we're going to have to calculate that z-score, and in this particular calculation, the z-score is 24 minus 30 over 8. This number happens to be negative 0.75. And if you look up negative 0.75 in your z-score table, you'll see 2266. And again, this sketch can be how you show your work, what you did, and how you arrived at your answer. So this 0.2266 is the answer to the question about what is the probability that the customer selected will require a replacement within 24 months. And finally, the next task, the last one here, it gets at the idea of expected value. So the company has a gain of $50 for each customer who purchases a warranty but does not require a replacement, and the company has a negative gain or a loss of $150 for each customer who purchases a warranty and does not require and does require a replacement. Sorry. What is the expected value? So with part B, I think this goes really, really well with part C. What we saw here, this right here, this is the probability that battery needs replacing for less than or equal to 24 months. And this just happens to be the same time frame for the warranty. So we know that the company gains $50 for each customer who does not need to require replacement. So they charge $50, but if the battery lasts longer than this, this is where the company they win or gain. Gain's probably a better word. They gain the $50. And on this side of the probability, this is going to be where the company loses. Company loses $150. And you can piece these two calculations together, these two values together, to find the expected value. So I'm going to put it on just a little more room here. So the expected value for this particular calculation, we have the negative $150. That happens with a probability of 2266. And we also have a lot more likely scenario. They gain $50, and that happens 77.34% of the time, or 0.7734. That's just the complement of this diagram down here, 7734. These two have to add up to 100%. Basically, either the company loses or the company gains, and those two probabilities have to add up to 100%. So then, just calculating that actually pretty quickly, you'll find that the company makes about $4.68 for each warranty that they sell. Again, expected values are not short-term; those are long-term gains. So what you'd expect to see is if they sell many of these warranties, that they'll make about $4.68 for every warranty that's sold. So that's the 2019 problem number 5. Thank you for checking out this video, and if you like this one, I'd like to encourage you to check out more. Feel free to subscribe. Thank you very much.